Good day, everyone. Today, we are going to present about our Digital Logic Group project, which is about Network Packet Transmission Monitoring System. We are from Group 6 and we are presenting about Option 6. Meet our team. My name is Ezra Lin.
Hi, I'm Evelyn Hong.
My name is Yan Jiarong.
And my name is Fatur Rahman Hakim.
So these are my teammates, and dedication and acknowledgement. We dedicate this project to our family and friends for their unwavering support throughout our academic journey. We sincerely thank Dr. Nurhaliza for her guidance and Dr. Muhammad Fuad bin Rohani for his helpful materials. Our gratitude also goes to the University Technology Malaysia staff for their assistance. Lastly, we apologize for any mistakes and hope this report benefits others.
These are the content of our slides. Their background, problem encountered, solutions, requirement, system implementation, as well as conclusion and reflection. So, what is network monitoring? Network monitoring is the ongoing process of overseeing and managing the performance, availability, and security of a computer network. The key components that we use for our project is test LED, count up counter function, comparator function, clock enabler function, multiplexer and demultiplexer, D flip-flop, packet data, passwords, 3D synchronous counter, 4-bit comparator, and logic gates, such as AND gate and OR gate. The problem that we encountered, the first one is system activation. The computer must be turned on to accept the input. Second, user input required. User must select source and destination addresses. And the third one, password protection. A password is required to complete the action. Clock activation. Push button starts the data packet transfer. Next, security concerns. To prevent unauthorized access to protect the privacy. Next is counter issue. The counter may increase even without data transfer. Lastly, user-friendly interface. The system should allow easy identification of source and destination using hexadecimal. For example, 1 for computer A1.
Solutions. Our proposed solutions consist of six key components: switches, a synchronous count-up counter, a comparator, a clock enabler, a multiplexer, and a demultiplexer. And to enhance security, our system use a multi-character password, 9D, instead of single character, to ensure that only the authorized user can access the system. We also implement hexadecimal addressing, such as 1 for computer A1 instead of the binary 001, making it easier for users to identify the source and destination address, and to prevent false and counter increments. And AND gate ensures that the counters increase only when data is being transferred. Lastly, the system features test LEDs, providing user with clear visual feedback on the system's status and helping them easily identify any malfunctions. Requirement. First is the transmission mode. The use of NOT and AND gate is to implement control logic. When the user selects a mode, the output will later include in clock enabler. And we have the indicator dashboard, which contains the test LED, which is used to show the status of each condition for clock enabler to the user, and to let the user detect whether the conditions for the clock enabler is fulfilled or not in order for the system to function. The decoders are used to implement password function. The password is one of the conditions for clock enabler. Only when the right password is selected by the user, the clock enabler will be able to function. And the D flip-flop in the count-up counter section is used as memory elements to store the state of the system or counters. The counter is age trigger and will update the output based on clock input for each data packet transmitted through the system. multiplexer and demultiplexer will both ensure the data packet is transferred from the correct source to the correct destination based on the source and destination address their user selected. There is also a sync data section which coordinates data flow between the source and destination selected by the user to ensure both of them are in sync. Address decoder is also used to decode binary addresses to specific source or destination addresses. And counterlap is used to track the number of packets that has been transmitted.
Next, I will talk about the system implementation. First is about the power on and initialization. The system is turned on initializing all components and clearing any previous data using the clear button. This step will provide smooth operation without any buffer. Next is the source and destination selection. The source address, which shows which computer will be sending the details selected using the source selector, which is multiplexer. The destination address, which is the computer that will be receiving data, is selected using the destination selector, which is the multiplexer. Logical connection between these selectors can ensure accurate routing. Next is the password validation. We have set up a password input mechanism to secure the system by using decoders. The user needs to enter the password, which is in case is 9D for this password. So we are switching. If the password match, the system proceeds to enable packet transmission. Otherwise, if you enter the wrong password, the system cannot be used until the correct password is entered. Next is mode selection using duplex control. Users can choose from these modes of data transmission, which is full duplection, that simultaneous data transfer in both directions, half duplex, which data transfer in one direction at a time. Next is simplex, data transfer in only one fixed direction. Logic gate and or not and indicator LEDs control and display the mode that has been chosen by the user. Next is the packet transmission setup. The count up counter is initialized to count the number of packets transmitted. The maximum packet transfer value is set using switching. A clock enable ensures synchronous timing of operations. The next is synchronization of data. Data is synchronized between the source and destination through a logic controls synchronizes mechanism. Logical gate ensure proper timing and alignment of data packet using the packet transmission. Next is indicators. There are several LED indicators are used to provide real-time system status, which help to read the ability of the user. First is the switch on, which confirms the system is power on. And second is correct password, which lights up when the correct password is entered. The third one is counter function, which shows active packet counting. Max packet transfer, which indicates the maximum transfer limit is set, and transmission mode, which displays the selected transmission mode. Ready, which indicates the system is ready for data transfer. And the last one is data transfer, which lights up during active packet transmission.
So the next one is clock activation. A manual clock button is pressed to activate the system's clock. This triggers the data transfer process where packets are transmitted from the source to the destination. Packet transmission and monitoring. The system monitors the transfer of data packets, counting each packet transmitted. The comparator function checks the data to ensure accuracy and consistency. Lastly, completion and reset. Once the packet transfer is complete, the system indicates the end of the process via the indicators. The clear function resets the counter and prepares the system for the next operation.
So for conclusion and reflection, design of the system has been successfully completed after a 2 weeks period. The objectives of this project have been achieved, in which we are able to make a network packet transmission monitoring system with some advanced features such as password validation using multi-character password. The system also provides a good user readability since the test LED is used to show the status of the system in every part. That's all from our team. Thank you very much.